Hello, ladies and gentlemen. Welcome back to Physics 20 Kinematics Lesson 1, the study of how things move, Part 2. Now, Eddie, the stupid puppy, runs west at 4 meters a second for 6 seconds. Then he turns and walks back east at 1.2 meters a second for 10 seconds. Two questions are A, what is his velocity average? And B, what is his speed average? Now, remember velocity is displacement over time. Now, in this instance, the displacement total. All right. Now, when I start asking for average velocity, like one of the questions in the homework and one of the questions on your test, so many people go, "Oh, it's 4 and 1.2. What's the average of that?" No, it doesn't work that way because he went different speeds for different times. You have to figure out his total distance. Now, remember what I said? North is positive, east is positive. So, Eddie starts here, and he went west. Displacement is velocity times time. He did 4 meters a second for 6 seconds, which is 24 meters west, or minus 24 meters. I would prefer to call it minus 24 meters, because then he turns around and walks back. Displacement is velocity times time. He went 1.2 meters a second times 10 seconds, which is 12 meters east, or plus 12 meters. Now, what's his resultant? Well, he started here and ended up here. Resultant would be minus 12 meters, or 12 meters west. And if I'm going to do the plus minus, then this is a minus 4 meters a second because of the direction. And this is a plus. So, what's his average velocity? Well, his displacement is 12 meters, or minus 12 meters. So, A, the average is displacement total over time, which is, sorry, 12 meters east. God help me. Yes, I can hear you screaming at me. That's west. No, that is east. Never mind. Can't read. Minus 12 meters. And the minus is the direction, or I could say 12 meters west. And the time is 6 seconds plus 10 seconds, or 16 seconds. So that is minus 0.75 meters a second. Or 0.75 meters a second west. That was his average. Okay? Now, just checking the numbers. I also have to calculate his speed. Change color. S. Well, his speed is how far he traveled. 24 meters and another 12 meters. His displacement, which is 12 plus 24. So that is 36 meters in 16 seconds, and I can't do that in my head, but Mr. Calculator will. 2.25. So his average speed was 2.25 meters a second, but his average velocity was 0.75 meters a second west. All right? Good. Now, one more quick question. Make certain you can do units. How long does it take light to travel 14,959,800 kilometers from the sun to the earth. The speed of light is 3 times 10 to the 8 meters a second. So we're looking for time. So first thing we do, here's the sun, light ray coming to earth. This is 14959,000 kilometers. Velocity is 3.00 times 10 to the 8 meters per second. So we've got kilometers and meters. I say we turn everything into meters so that we don't have to change our units. I was going to say I should change colors. I'll make that green. I haven't done green in a while. There we go. Now, velocity is displacement over time. Now solving for time, multiply both sides by time. So displacement equals time times velocity. Now we want time by itself. How long? That's time. So I would divide both sides by velocity. So time is displacement divided by velocity. Now, kilometers to meters, kilo means 1,000. So you should be able to do 149,598, sorry, 0.000 meters divided by 3.00 times 10 to the 8 meters per second. Now, no, I didn't show you how to turn kilometers into meters. We've done enough of that. You should be able to. The real trick here is, can you put it in the calculator? Okay, 149,598,000 divided by 3 exponent to the 8, not times 10 to the 8, because then you'll divide by 3 and multiply by 10 to the 8. And I got 49.8. 6 seconds. 1, 2, 3, 4, 6, 7, 9. Okay. Hang on. Just double checking my math. 9, 0, 0. Yep. Sorry. So I got about 50 seconds. Okay. Any questions about that? Good. If there's no problems, go do the classwork and homework, and I'll see you in class tomorrow. Good luck.